So now that we know a little bit about MIDI, I want to talk about different types of MIDI devices, different roles that MIDI devices can play, and different reasons they might want to be communicating with each other. So in this video, we're going to talk about some basic types of MIDI devices, controllers, responders, which is a kind of special term I've come up with, and I'll explain why in a minute, sequencers, interfaces, and virtual devices. I want to make a really important point here, which is that it's fairly rare to find a MIDI device that only fulfills one of these roles. The real world is a little bit blurrier than this, and many of them fulfill more than one of these roles. But I think it's still very important to break them out by these roles to see the different parts that they can play in a kind of ecosystem of devices that are interacting with each other to make music. And I want to show you again, in the original days of MIDI, the way that they all communicated with each other was with a MIDI cable like this. And so every MIDI device would be connected to every other MIDI device via a MIDI cable. Nowadays, MIDI cables are still used a lot, but there are other options as well. There are USB connections, and there are virtual connections on a computer, connections over a network, and so on and so forth. So let's go ahead and start with controllers here. Controllers are essentially a MIDI device that sends out MIDI messages, but that's its primary role. So here we see a picture of a keyboard. That's obviously the most popular kind of controller, with a foot pedal and a couple sliders on the side of it. That's what I'm using in the lab here. You can see I've just got this little 25 key MIDI controller, and this is what I have hooked up to the computer to make all the sounds whenever I'm playing MIDI for you in the videos in this module. The key point to make here is that these things don't actually make sound themselves. I guess they make a little bit of sound. If I bang the keys really hard, you can kind of hear key banging, but that's just acoustic sound. They're not actually making any sound related to the notes that you're playing. They don't have speakers on them. They don't have headphone jacks. They're not synthesizers or anything like that. They're just sending MIDI messages. So they don't really become a musical instrument until they're hooked up to something else that's making sound in response to them. So I think that this is a really important point about controllers. Obviously, you can have controllers that have a built-in a sound module in them to make sound, but many of them, like the one in this picture, like the one I just showed you, are just sending MIDI messages saying what note is being hit, and some information about that note. There's obviously a lot of different kinds of controllers besides just the popular keyboard controllers. Just about any traditional instrument you can imagine has a MIDI controller that goes with it. There are MIDI wind controllers that have saxophone fingerings, like the ones in this picture. They even usually have breath sensors to sense how hard you're blowing into the instrument and send MIDI information based on that. There are MIDI drum sets, there are MIDI trumpets, MIDI French horns. Anything that you can imagine pretty much has been turned into a MIDI controller that sends out MIDI messages. Again, when you blow on this MIDI wind instrument, it's not making any sound itself. It's just sending out MIDI messages. There's also some very unusual MIDI controllers, and I wanted to give you two examples right now. One is the drumitar. It's also known as the Zen drum. Which was invented by Future Man, the drummer in the band Bela Fleck and the Flecktones. It looks a little bit like a guitar, but it has a ton of buttons on it, and each of those buttons triggers drums. And Future Man actually performs it as if he's performing on a drum set. The other example that I want to point out is a fairly old one. This came out in the early 90s, the Buchla Lightning. And this is a series of two wands that you can actually wave through the air, and there's an infrared sensor. And you can set it up in all different kinds of ways to send different types of MIDI messages based on what you're doing. So it might be looking for a hit, as if you're doing a virtual drumming or air drumming or something like that. It might look for a particular area in space where you're waving the wand. It might be looking at how fast you're waving it. All different kinds of things like that. So I'd like to take a moment and look at some videos demonstrating these two novel controllers. The drumitar and then the Buchla Lightning. And remember again that these are MIDI controllers, so at the end of the day they're sending out MIDI messages that are being interpreted by other devices to actually make sound. And then the final example I want to give was of pitch to MIDI converters. So these basically can take audio from a microphone and then run an algorithm to try to figure out what pitch is being played and send a MIDI message based on that. So that can essentially turn any instrument, if you will, into a MIDI controller. So that's a view of some controllers. I want to talk about MIDI responders now for a second. And I'm using this, I'll warn you, no one else calls them MIDI responders. Everyone else calls them MIDI sound modules. And most of the time we're thinking of sound modules, something that receives MIDI messages, like all the different things on this rack here. Say a note on message and then plays a note and sends out an audio signal based on the MIDI messages that it's receiving. The reason that I'm calling them responders here is that they're not limited to just sound modules. Anything that's taking a MIDI message and doing something based on that, creating something based on that, could be thought of in this device category. And to give you an example of that, robots can be MIDI responders. This is a robot called the Guitar Bot. And it was developed by a group in Brooklyn called LEMUR, the League of Electronic Musical Urban Robots. And it receives MIDI messages, and based on it, it plays these 4 strings, 1, 2, 3, and 4, at different pitches and plucks them at different rates, again, just based on the MIDI messages that it's receiving. So this is not a sound module, it's a robot, but it's still a MIDI responder. There's a video of this robot in action playing in response to MIDI messages, a piece composed by a composer named Joshua Freed. So go ahead and take a look at that for a second. So that's what MIDI responders are. And now I want to talk about MIDI sequencers. MIDI sequencers are geared more towards composition and editing of MIDI data. So instead of just playing live, hitting a note on a MIDI controller and expecting a responder to respond, you're recording data coming from MIDI controllers and perhaps editing it by hand even, and then you're playing it back. So this is Reaper's MIDI sequencing capabilities here, which we'll get into more detail about in coming videos in this module. So you can see how it's organizing on multiple tracks here. We have MIDI data on these different tracks. They can then get edited. It can also get sent out to different MIDI responders to make sound. And so MIDI sequencers are really taking MIDI messages out of just real time with the ability to capture and transform and then play them back. In the early days of MIDI, sequencers were often seen as hardware sequencers. I would buy a special device that would actually do MIDI sequencing for me. But these very quickly moved to the realm of personal computers and computer software because GUIs and mouse control and large screens and all of that, all the things that computers do really well, turns out that those are really important for MIDI sequencing. To be able to see the data and edit it and manipulate it like you can in this screenshot is really hard to do on a dedicated hardware device. One other type of MIDI device here I want to talk about are MIDI interfaces. So obviously every hardware device has a MIDI interface on it. This keyboard, for instance, it has MIDI in and out ports on it. These right here where my fingers are, if you can see those. But there's also dedicated devices, particularly for personal computers, because your laptop probably doesn't have a MIDI in, out, or through port on it. It does have a USB port. And so nowadays when we see MIDI interfaces, they tend to look something like this, where you have MIDI in and out ports right there that you can plug MIDI cables into to connect to external devices, then a USB port that actually lets you hook up to your computer. So that's what we typically think of as MIDI interfaces. There are very fancy MIDI interfaces out there as well. Interfaces that might have 8 MIDI ins and 8 MIDI outs and let you do very complex routing of any input to any output and so on and so forth. That are really like these, almost like these network switches at the center of a studio with a lot of MIDI hardware. The final class of device I want to talk about are virtual devices, and these are incredibly important in how we work with MIDI today. These are ones that they don't have any physical counterpart, but they just exist on your computer screen and a software inside of your computer. There's virtual MIDI controllers. This is the virtual MIDI keyboard that's included with Reaper. You can use your mouse to play it. You can also hit different keys on your computer keyboard, and that'll actually trigger different MIDI note messages to go out. And there's MIDI responders, MIDI sound modules that exist as plugins on your computer. This is a Resynth, one of the ones we'll be using in this module, a very, very simple one that, that ships with Reaper. But there's extremely complex and rich sound modules that are available just as software on your computer as well. Ones that sometimes even go down to replicating every last detail of a piece of hardware, down to the power cable and pretend audio cables that come in and out of them, and so on and so forth. So there's a really rich world of virtual devices that exist inside of our computers as well. I want to make one final point here, and that's I really want to emphasize the fact that MIDI at the end of the day is just data. We have, we might have some controller that's sending out MIDI messages, some kind of responder. And the controller might have one thing in mind when it's sending that data out. The responder might have something very else in mind when it's interpreting that data. Because MIDI is at the symbolic level, it's open to interpretation by each individual device. And to emphasize this point, what I just wanted to mention that MIDI is actually used to control lighting systems a lot in theatrical contexts. So something that doesn't even have anything to do with music. So you might have your controller might be a MIDI keyboard, but your responder might actually be lights. So every time I hit a note on my MIDI keyboard, instead of playing a note, I'm actually triggering a light to go off in a performance space. And I have a video that demonstrates this really well. You'll see the MIDI keyboard, and you'll see someone playing it, and they have it hooked up to a sound module, so you can actually hear the notes that are being played. But then you'll also see this array of different lights, and each different note that they play is actually turning on a different light in the lighting system. So I just wanted to show this to emphasize the fact that MIDI is just a data protocol at the end of the day. And it's up to each individual device to create and interpret these messages in different ways, depending on what their intents were and depending on how they're configured. So to review here, what we've looked at in this video are various types of MIDI devices. And we've talked about the role of these devices in creating and interpreting MIDI data. In the next couple of videos, we're going to delve into detail about what that MIDI data actually is. We're going to look at the structure of MIDI messages and some important parts of the MIDI specification.